Hi guys, today we're going to be talking about classes inside of Python and classes and objects in particular. And this is one of those core concepts in programming that has been around for the better part of 30 or 40 years because it is so useful for writing code. Now, what classes do is they allow us to encapsulate data in an object or into something that we can represent a real life thing. And that's why it's called an object or object-oriented programming in some respects. Now, Python does it a little bit different than other languages do it, but it's the same idea regardless of what language you use. So we're going to introduce this using Python, and we're going to walk through the basics of what a class is, and then we're going to look at how to create an instance of a class, which is an object, and then we're going to look at how we can use this in code, and then of course we're going to have a challenge to go with it. So let's dive right in and try to wrap our heads around what a class is and then what an instance of a class is as an object. So what is a class anyway? This is a definition I came up with that kind of encapsulates what it does more functionally. Now, if you ask some people that were other than me, you might come up with a different idea of what a class is. The idea of a class, though, is one of those things that's better described or shown than it is to really define in a single definition. But I tried, and this is what I came up with. It's a code structure that defines a set of properties and methods that are used to describe something. So a class, in the idea that's more abstract, not in computer science, if I have a class of something, I'm talking about a group of items or people or things that are similar to one another. They all have common properties and they all do different things, but that are similar to one another. So if you think about your class of students, you're all students that are learning, and you might have things like your grades, your name, you're a freshman, you're a sophomore, things like that. These are properties, and you also do things associated with your class. That is, you learn, you write, you do math, you do all these kinds of things that are oriented around being a student or being part of a class in that respect. So the idea of a class is just that you have some kind of definition of properties and attributes that you might assign to that class, and then things that they do. And so that's the idea of a class that gets translated into code. So we have things like properties and things that we can work with according to those properties, and we create code structures that will kind of group those together. And then we will have what we call properties and methods on the implementation of that in our code. an instance of a class in the most abstract type is called an object. So an object can be, anything really. I mean, it's an abstract idea. And so if I have a specific class, say a person class, the instance of that person class would be an object, and that person could be me, it could be my wife, could be my kids. We're all persons, and the most general idea is that all instances of every class are objects, but a specific class will have an implementation of a specific instance of that class. It's still an object, but it's a type of person if I was using a person class to define that. So an object is just a general term to refer to all instances of all classes. Try not to get wrapped around the axle on this terminology, though. It's just used a lot in computer programming. If you hear somebody talking about an object, just understand that it's an instance of a class. And if you hear a class we're talking about in programming, it's usually talking about the definition of that object. And we'll get our heads around this a little bit more when we actually look at an example. I think it'll be a little clearer then. Each object has properties of that class, and we've talked about this already. And the great thing about an object is because it's an instance of a class, the object is not like all the other objects in that class, a particular class of object, that is. I have a different name than my wife, so we are still people, we're persons, if you will, but we have different properties that have different values. So we have the same property that is a name, but it has a different value to it. My name is Blaze, my wife's name is April. So that is similar in code as well. So every instance of a class is called an object, and every object can have properties associated with it that have different values from another instance of that same class. This will become a little bit more clear when we look at an example 2 in just a minute. And also, methods on classes are used to work on those properties. Now, we have talked about functions, and functions in Python we use to create a piece of code that is abstracted away so that we can use that piece of code over and over and over again. Well, we can take that same idea and apply it to a class, and where we have a function that is associated with a set of properties, and then that function can work on those properties just like we saw whenever we were using them in the more general context, but it will be related to the actual instance of the object that I'm working with. And so I don't have to pass parameters in it, I can just use it, but the parameters for a given function can actually come from the object's values, and we'll see an example of this when we look at an example here in just a second in the code. So I have on the screen an example of a class here, and I want to point out a couple of things about this code that I think are kind of confusing for a lot of new developers when they start to see object-oriented programming, which is what we're talking about, and when we start to introduce the idea of classes. Now, the first obvious thing that we see here is this new keyword called class. Now, class is what tells Python that I'm declaring a class. And so this code block that I have here is a definition of a class. So when the Python compiler sees this, it's just going to say, okay, this is a definition for the person class. So if I was to declare this class and I was to do a type on it, like we saw earlier on when we did type for strings or types for floats or types for integers, I would get back person as the type for anything that uses this particular class. And an instance of this particular class is, as we said, it's an object. So this is actually defining the class. We haven't got to the object portion of this yet, but we'll talk about that a little bit as we go through this, because in this code, we're actually looking at a self-reference to an object, which brings me to my next point, which is this particular method or particular function right here. Now, on this function, we have a def, like we saw with other functions, and we have this def right here, which is defining another function that we'll talk about in a moment. So this class has two functions associated with it, this init function and this greet function. Now, the init function is a special function that is used to set up an object whenever we declare an instance of a particular class. So this init method is, or init function is called a constructor. And in other languages, it's referred to as a constructor. If you're talking in Python, you might hear it referred to as an init method or as a constructor, but it's basically a special method that is part of a class that sets up the initial state of that class and the instance of that class, that is, as an object. And it has, on this particular one, 3 parameters that I'm passing in. These 3 parameters are not unlike other parameters that we've seen with functions, but one of these is a special parameter. It's the first parameter that I pass in, and this instance calls it self, or this particular class calls it self. The self parameter here references the object that I'm going to be instantiating from this class. It's a self reference to the object itself. And so it's basically like looking in a mirror and saying self dot something, or, I'm looking at a mirror and I'm saying your name is Blaze. And this is kind of a self reference to that particular object that I am creating from this class. And so this can be a little bit confusing whenever I start talking about a self-referencing object. The self keyword here, it's not really a keyword, it's just really a parameter. It's pointing to the object within the context of the object itself. So that's going to be a little bit more clear when we actually look at an instantiation of an object, but I want you to kind of get your head around this when we're talking about it, because it's just basically understanding that self points to an instance of the object from within the object. These other 2 parameters that I have here are inconsequential. These are just parameters that get passed into the constructor that are used to set up the initial state of the object whenever I declare it in my code. So this one takes 2 parameters, name and job. I could have none, I could have 10. The point is that I can have as many of these as I need to initialize my particular object that I'm doing right here. And notice what this is doing in this code right here. It's doing self.name equals name. Now, this self.name is not the same variable as the name parameter right here. So this name parameter is not the same as the property on self.name. By doing this, what I am doing though is I'm taking the value that was passed in right here on the parameter and I'm assigning it to a property on the object. And the self object, the self here is referring to the object that I'm creating, and the name property is taking on the value of the parameter that was passed into the init function right here. So this can be a little confusing for folks that are originally discovering this. They're saying, why do I need to do self.name equals name? That seems kind of redundant. Well, what it's doing is it's taking this parameter, which is not a property on the object, and taking the value from that parameter and assigning it to a parameter on the object. Even though the parameter has the same name as the property on the object, they are not the same variable. They're not even the same. They're not even on the same object. This is just a parameter. This is a property of the object. And that's one of the things that can get confusing when folks start looking at this, is they say, well, I see name twice in there. Why is one have a different value than the other? And that's because this is not the property. It's actually just used to assign the value from the name parameter to the property on the object called name. And this is a common construction in code that you'll see a lot in Python and other languages, where the parameters that get passed into the init method or the constructor get assigned to a property on the object that has the exact same name. And it can be a little bit confusing, but understanding that if you see a reference to self and then a dot and then some kind of text after that, that is referring to a property. So it's that dot that's going to denote that, oh, I'm referring to a property. If you don't see that, it's referring to a parameter or variable that's kind of outside of the object itself. And the same is true for the job right here. So I have self dot job. That's a self-referencing to the object. Job property on the object equals the job parameters value. And so that's going to just basically take the value from the job parameter and assign it to the property value on the object. And so that is how I initially create an instance of my object and initialize the values of that object using this init method. Now down here, I have another method or function called greet. This is not a special function or method. It's a function that is associated with the person class. And notice what this has on it. It has the self as well, like we saw up here in the init method, but this is also referencing the object itself. So it's a self-reference back to the object that contains this particular greet method. And so what this is going to do is it's going to say, it's going to return something. It's going to return a string. But notice that I'm not passing any additional properties or parameters into this particular method. It's just taking the self parameter right here. And this self parameter refers to an instance of the object, and it will have associated with it self, and then it will have the properties that I created up here inside of my constructor. So this will have a value for name, and this down here will have a value for job. Even though I didn't pass those in as parameters to this particular method right here, those are accessible because of self, and they were assigned up here inside of this init method, but they are referenced down here inside of this function or method. And so what this is doing is just basically taking the values of that property and building a long string and then returning that back to whoever called this. So let's look at an instance of this where I'm actually going to declare an instance of person and then do something with it. So let's take a look at this in a slide, and then we'll go over to the IDE and then look at it there. Okay, so now I want to look at how to instantiate a class. Now, we've looked at this code already. I beat this already to death in the last discussion, but I have it here for reference because I want you to see what's going on. So down here, I have a variable called Blaze, and I'm setting Blaze equal right here to person. Now, I'm passing into person 2 parameters. Now, I'm passing in Blaze and programmer. Now, this declaration right here has 2 parameters on it. But what's interesting about this particular declaration is that by doing this, I'm actually calling the init method that has 3 parameters on it. But what this is doing is actually calling the init method right here by just calling it, I don't have to do like a .init. By doing a person and then opening parentheses and passing in some parameters, it's going to call the init method right here, or init function, and it's going to inject the self as the first parameter, and then anything else after that, it's going to add from the parameters that I pass in here. So this has only got 2 parameters on this actual call into the init method, but Python is going to insert self as the first parameter, and then it's going to take all the other parameters that I passed in and then assign those to these right here. So this will get the value Blaze, and this will get the value job. And then, of course, it'll do what we saw right there on the last slide, where we take the name from the parameter and assign it to the property name, and take the value from the parameter job and assign it to the property job. And so this one then will call blaze.greet, and it's going to call this function right here, this method, and it's going to return this string right here. And notice that I didn't have to pass any parameters into that method either. And again, it's going to substitute the first parameter as the self-referencing object itself, and then it's going to give me access to the properties on that object using a dot notation like this. So self.name and then self.job. And so this would print out right here, if you can guess, it would say, my name is Blaze. I am a programmer. And then down here on this instance of the class, in this object called April, I have April and the job is mom. And then if I did the return on this right here, I'm going to assign, again, name from the name parameter to the name property, the job parameter to the job property. And if I called April.greet, again, I'm not passing in a parameter. It's substituting the first parameter to a self-reference to the object itself, and I can access the properties on that. So we would say my name is April. I am a mom. And so you can see there where I am actually creating a string from creating a instance of my class using the init method as an object. This object is called Blaze, and another object of the same class called April. And so this is an important distinction here, is because although these are using the same class, they are two instances of the class. So I have two objects that are of the type person, and they use the same code, but they have different values for the property. And so I get different behaviors for those different kinds of people that I'm using for this particular person in class. So this is how you instantiate objects from a class. You essentially just call the person class like you would a standard method, like, or standard function like we saw already with parameters on it. But instead of just calling the init method directly, you just simply pass in the parameters like we saw right here, and it's going to interpolate that as calling the init method or the constructor, and it's going to inject, again, self and then the two parameters that I passed in down here. So that is how Python handles initializing a class through the constructor, and then also calling a function on that class right here. It's by providing that self as the first parameter on the functions in my class, and then also on the init method in my class as well. So these are some examples of objects that you can use. So let's go over to the IDE and see this in action. It might help clear up any confusion that you see here, and might make it a little bit clearer as to what I'm actually talking about here. We'll use this example since I've been using it on the screen, and I'll code this up and you'll be able to see it in a live demo whenever I'm walking through it in the IDE. Okay, I'm here inside of Python in my IDE Tony, and I want to craft this particular class that I have here. I'm going to code this up using pretty much what we saw on the last slide. So I'm going to start with class. I'm going to call it person, and notice I have the class keyword, and that's my name of my class. And then I need to declare my init function. So I'm going to do def __ init __ like that. And then I'm going to open up my parenthesis, and I'm going to put in self as the first parameter, because my constructor or my init method needs that as the first parameter. It's going to assume that it's there. And then I'm going to pass in the other parameters that I have. And I could also add in a third parameter just for good measure here, so I'm just not copying what I just saw before. This one is going to add the age property to it, and I want to add the age parameter into my init method. So I have the self here that's going to be a reference to the new object that I'm creating, a self-reference to the new object I'm creating, and these are the three properties on the object or the class I'm going to create. So down here in the code for this, I need to add in a colon, of course, because it's a code block, and I'm going to do self, and I'm going to do dot name equals name. And so that's going to take the value of the name parameter and assign it to the name property. And so that's what that's doing. And I can pretty much copy and paste this code for job like this, and job like that, and age equals age. So I'm basically populating the properties on my self object here, a self-reference to my object, and then I'm going to take the value from the parameter and assign it to the property. Value from the parameter to the property. I'm emphasizing this just so that you know that this age is not the same as this age. They're different variables, but they have the same value. So that's why I'm emphasizing that. So once I have my init method done like that, I can have my new method. Let's call it greet. And so I'm going to call this one greet. Notice I don't have any parameters on this other than self. And so this is going to get the first method the first parameter on this is going to be called self. And self is, again, a self reference to the object that I've created. And so I can then reference something about the object using the self parameter here. And that's what I'm going to do for my return on this. You don't have to do a return in a method, but in this case, I am doing it. It's just like a function that we saw already. You don't have to return anything in a function. A return will return something if you declare it as such. But in this case, I'd only have the self pointer essentially to the object that I want to use in here. So I'm just going to return something about this. I'm going to say hello, my name is, and then I'm going to do self.blaze, and then I'm going to do a another part of the screen, add something like this, and I'm going to close that up and say I am a, and then I'm going to do plus self.job, and then I'm going to add some more text to this, and it says my age is, and then close this up, and then do say self.age, and I need to do a plus, of course, and then of course I'm going to add the period at the end of the sentence, so it is good grammar. So this should print out, hello, my name is something, self.place, would be name right there, self.name, self.job, self.age, in a string that is going to be returned back to whatever calls this. So let's go ahead and create an instance of this object here. So let's do a new instance. I'm going to call it, let's call it AG. That's my daughter's initials. I'm going to say self equals person, and I'm going to call her AG, and that's her name. Her job is student, or I could put first grader or whatever, and her age is 6. So AG is a student and she's 6. And then let's do my second instance of my object, and this is going to be EE. This for my second daughter, and she is a toddler, and her age is 3. So if I print ag.greet, I should get back some response. This is hello, my name is AG. I am a student. My age is 6. And then the same down here. Hello, my name is EE. I am a toddler. My age is 3. And so let's see if this code works. I might have a typo or two in it, so I might have to do a little bit of debugging, but because I'm doing this from memory on the fly, so let's just save this off and run it and see if it works. I got a syntax error. Yep, that's not going to work. Can't do that. Can't do that either. So let's see what happens. Okay, just like I thought. So not as many errors as I thought, and so clean code here. And so there we see it. Hello, my name is AG. I am a student. My age is 6. So by creating an instance, this is an object right here, and it's calling the init method when I do this. So let's see if we can step into this code right here and see what happens. So let's debug it. I'm gonna stop this and then debug it right here. And let's do a step into, and let's see if it calls into this particular object in here. So step into, it's gonna come up here, gonna assign the parameters, student 6, and it's going to come up here into, it's going to pop up in a new window, and notice what it's calling is my init method. And so this is where I have the init method right here that's been called as a part of my person object. Notice it's got person AG6, and so the self is referencing the object that I'm creating, and these are the parameters that I passed in when I said person AG student 6. And now it's going to create an instance of this object. So let's see, step in, I can just step over name AG. Now it's getting its parameter job, value student, age, value 6, and now it's calling back to my code. And then it's going into print, and then going down into the greet method. that is on my class. So let's see it go into that method here. Let's see if it goes into there. So it's popping up a new window. It's got the method greet, and it's got a reference to self right here. I didn't have to pass in any additional parameters, and it's doing hello, and it's going to consolidate this down into the string using the concatenation like we've done with strings already, and it's going to compile that out. It's just getting pointers to objects and things like that. And then once it's got all the appropriate parameters, building the string up, and it's going to return that. And now I've got my string right there built from all of the parameters I passed into my class. In this case, it's going to create an instance of that called AG, and it's just printing out the output from this particular method right here. So I can just continue to run this through to the end. So we saw it step into the init method. We saw it step into the greet method here. In my instantiation, it went to the init method, and here it went to the greet method. But it noticed it's applied the self parameter as the first parameter on each of my methods up here, but then all the other parameters were what I passed in after that. And so it just simply appends those to the particular function up here. So that's how it works inside of Python. So again, a very straightforward way to create encapsulated code that is associating a bunch of properties with some methods that go along with those properties, and that's what we call a class. And then you wrap that up and get an instance of that, and I just call it an object. So this can be a little bit tough to get your head around, but as you practice it, it will become a lot more clearer. But it's also a very powerful feature of any programming language, because this is going to be very extensible, and we'll look at how we can do that in a future lesson. But one more thing I want to look at before we go to the challenge. Okay, so one last thing I want to look at is the ability to create lists and tuples of objects. Now, with a class, you can actually put lists inside of your classes as one of the properties. You can put other objects inside of your classes as a part of your objects. Now, I'm not going to get into that, but I want to introduce the idea of having a list of objects, because this is going to be applicable to the challenge, but it's also going to show you how you can use some things that we've talked about already, lists and other data structures, and use those with more than just the basic kind of data types that we've been talking about up to this point. So this is the class. I just have it here for reference, and I'm not going to go back through that, of course, but this is the class I've been working with. Now down here, I have this variable called people, and it is a list because I'm using these square brackets right here. And inside of my list, I have a reference to my person class right here, and I'm calling the init method right here. I'm giving it the parameters that are basically hard-coded in this code. I'm not assigning this to an external variable. It's just getting assigned to the first index that is a part of my list over here. So people 0 would be person Blaze programmer, and then people 1 would be person April mom. So this is the second object inside of a list of objects that and I'm calling my list people here. So I can use people as a list, or I could call this is just the variable name, and I can have lists of objects like this. I could also do the very same thing with tuples as well. So if I wanted to create a dictionary, I could have a dictionary where the value of a key value pair is an object. So this allows me to have the ability to have lists or tuples or dictionaries of objects, and then I can treat those just like I was doing with strings or integers or floats in lists. So I am not bound by the basic data types in Python. When I create lists, I can use objects inside of my lists as well. And so if I wanted to reference that, I can just do exactly like I did when I was referencing them, and then I can actually call methods using a dot operator. So if I wanted to reference the greet method, I would just simply pull up people 0 and then do the dot operator, and then I would have greet, and I would call that method on people on the first index of my people list right here. And so that would print out my name is Blaze, I am a programmer. and it would print that out because it's getting back the string right here. So let's go over to Tony and do something like this, and we'll type this up, and then we'll create a list, and then I'll show you how you can instantiate this very easily, and then we'll call a print function or something like that. Thanks for your submissions this week. And this week we have submissions from Madison B, Samuel G, and Jacob G. And Samuel G will be getting the gift card for this week's. Congratulations. So the challenge, I want you to implement a deck of 52 cards, similar to what we did in lesson 6. So actually you can use the code from lesson 6 as a reference point, and I'm going to link my example where I did that as well. And you can use that as a launching point for implementing a deck of cards. But I want you to use a class instead of just using a list like we did in that particular lesson. So your class would basically have two properties. You would have the value of the card, which would be 2 through 10, Jack, Queen, King, or Ace. And then you would have the suit. That would be diamonds, spades, clubs, or hearts. And so you could use the suit and the value as the properties. And then I want you to have a method called show, and that basically just displays, it takes the two properties and creates a string, right? Like we did with greet in our example, and it just prints out king of hearts or 2 of diamonds, whatever the value and the suit may be. And then you would want to return that as a string. And then I basically want you to create a method that will create the deck as a list or whatever collection type you want to use. List is probably the easiest one to use. And then from there, loop over that particular deck however you see fit, and just display the cards using the method that you created. And that's what I would want you to do for the challenge. So let's go over to the code repo where I am going to show you where you can get a reference point for what I'm asking for, and then I want you to extend it. So here's the code repository that I referenced on the slide. You can go to lesson 6 and look at lists, and then click on deck.py to get a basics for the challenge right here. So what I want you to do is kind of take this code or something like it and modify it. This one right here, though, is just using a deck that is a list, and it's building a string, and it's using this for loop right here to build a string that represents a card. I want you to create a class that has the properties that I mentioned on the slide, that has a value property and a suit property. And instead of using a string, create an instance of a class, and then instead of creating a card string and assigning it back to or adding it to my list, add the card to the list instead of just a straight up string. And then I want you to create a loop to loop over the deck and then print out the particular card suit combination from a method that we saw, like we saw when we looked at greet, whenever we were looking at our example inside of the slides, and then the code samples there. So if you want to look at the code samples, they'll be in the repository for this week's lesson, and you can use those as a reference. But I want you to create, again, a class that has two properties, value and suit, and then create a method on that particular class called show. And then I want you to loop over the deck list right here and print out the cards in the deck back to the console. So that's the challenge for this week. So I'm looking forward to seeing what your submissions are going to look like. Just to give you an idea of this, I'm going to go over to Tony and show you what I did to implement it, but I'm not going to show you my code. Okay, here's my code that I have. You can see there I have my class card, and so I'm using a class inside of this particular example. Let's run this, and this is what I want you to do, is just print out the particular value and suit of each card that is in my deck. Now, my implementation is based on the code that I saw in lesson 6. I'm not doing any shuffling on this or any drawing. I just want you to implement the card class based on some of that for loop logic that we had already. I'm more interested in seeing how you implement the class and seeing you use the class in a loop that will then print out the particular values and suit of each card. So that's my implementation running. So you can use something like this. So looking forward to your submissions, and thanks for watching Cool Enough to Code.